start with CH4. So now I'm going to apply all the steps we discussed. So carbon is in group 4, 4 valence electrons. Hydrogen is in group 1, 1 valence electron, and there are 4 hydrogens in the molecule. So 1 times 4. So the total number of valence electrons is 8. The step 2 is you decide the central atom. The central atom is carbon. Now make the skeletal structure. So there are 4 hydrogens as terminal hydrogens. So those are the 4. You combine or connect the central atom and the terminal atom using a single line. So that is the skeletal structure. So let's keep track of the electron count. Initially there were 8 valence electrons. To create these 4 lines I used 8 electrons. Each line 2 electrons. I created 4. So 8 electrons. Now what is left is 0 valence electrons. So there are no electrons to distribute. So we have used all. So that is the Lewis dot structure for CH4. Now you can count whether carbon has octet and hydrogen has its due number of electrons. I'll mention that in a second. So carbon, around carbon there are 8 electrons. 4 bonds, that means 8 electrons. So the octet of carbon is complete. For hydrogen, hydrogen has 2 electrons. Those 2 electrons belong to hydrogen as well because they are being shared between carbon and hydrogen. So hydrogen has 2 electrons, not 8, which is the right number because hydrogen cannot have more than 2. So hydrogen can have duet, just 2 electrons. That is the maximum hydrogen can have. So in this case, the hydrogen has its duet, 2 electrons. If you want, you can calculate the formal charges. I'll let you calculate, but I'll write it down just to show you. For carbon, it is 0, the formal charge. For hydrogen, it is 0. So the formal charges of all these hydrogens are 0. So that is the Lewis dot structure for methane, CH4. So let's look at another example. Let's say phosphate, PO4 3- ion. If I calculate the total number of valence electrons, phosphorus is in group 5, so 5 valence electrons. Oxygen is in 6 valence electrons. And there are 4 oxygens in the molecule. And for the anion, the negative ion, we have to add electrons. We have to add 3 electrons. So it is 32 valence electrons. Central atom is going to be the phosphorus, and there are 4 oxygens as terminal atoms. So let me put them as this. So those are the terminal. Then you create the skeletal structure by making just one line, one bond between the central and the terminal atoms. So initially there were 32 valence electrons. To create those 4 lines, I used 8 electrons. Now there are 24 left. So now what you do is you take those electrons and complete the octet of terminal atoms, starting from the most electronegative. In this case, all are oxygens, so they are the same. So there are 24. I'm going to place 6 on this oxygen. That will give that oxygen 8 electrons. 6 here, 6 there. I can do that because I do have plenty of electrons. So now I have placed 24 electrons, 6 times 4, 24 electrons on terminal atoms. Initially there were 24, and then I placed all 24. Now I don't have any valence electrons left. So now we have to check whether our structure is right. How do you check it? By checking the formal charges, right? So let's look at the central atom, the phosphorus. The formal charge of phosphorus, if I calculate, it is +1. We just calculate it using the formula. I'll do it without writing in letters. So phosphorus has 5 valence electrons, and it does not have any lone pairs, so it is 0, and it has 4 bonds around it. That means 8 electrons. We need half of that, which is 4. So the formal charge of phosphorus +1, which is a red flag. +1 is red flag. Okay, so we have to get rid of that. We know how to get rid of that by making a double bond. You take one pair of these electrons and share it with phosphorus. If you do that, you get this. Now you have phosphorus. We shared another pair of electrons with phosphorus, so made a double bond. We did not do anything with other oxygens. So now the formal charge of that central phosphorus is 0. If you look at the oxygens, I'll just write it down. So the formal charge of phosphorus is 0. This oxygen is -1. This oxygen is -1. If you don't know, just calculate it and see. This one is 0. Okay. I want you to see one thing. If you add all those formal charges together, in this case there are 3 minuses and 2 zeros. If you add them together, that number, that sum, equals to the charge of the ion. Okay? -3, that is the sum of the formal charges, which is equal to the charge of the phosphate ion. Okay? So there is one double bond and 3 single bonds. I assume you understood what we just did. Let's do another example. Let's take nitrate. Before I do nitrate, I want to point out one thing. If you look at the number of electrons on phosphorus, okay, number of electrons on phosphorus, there are 5 lines. That means 5 bonds. Each bond is 2 electrons. That means around phosphorus there are 10 electrons. So that is more than 8, right? Normally these elements, they try to get octet, complete their octet. But that central phosphorus, it has 10 electrons. So some elements can do that. Especially, just keep this in mind, elements in period 3 and above. So when I say above, I mean period 4, period 5, like that. The elements in period 3 and above can have more than 8 electrons when they are the central atom. So just keep that in mind. So I'll write it down. Again, when I say above, I mean period 4, 5, 6, like that. Okay, so what are the important words in here? Elements in period 3 and above. That is important. Can have more than 8 electrons, more than 8 electrons, more than the octet, when they are the central atom. That is a key word. So what this means is, if they are the terminal atoms, they cannot have more than 8 electrons. They must have 8 electrons. Only when they are the central, they can have more than 8. So when you see this statement, you need to understand that then the elements in period 2, for example, cannot have more than 8 electrons. So that is, you need to understand that one. So let's look at this nitrate ion, NO3 minus. Okay? So nitrogen in group 5, 5 valence electrons. Okay. Oxygen group 6, 6 valence electrons and there are 3 of them. This is an anion, negative ion, so you have to add 1 electron because the charge is just 1. So the total is going to be then 24. 24 valence electrons. So now let's draw the Lewis dot structure. Central atom is nitrogen. It is nitrogen. There are 3 terminal oxygens. Now I create my skeletal structure by creating a single bond between the central and the terminal. So 3 of them. Initially there were 24 valence electrons. So to create 3 bonds I used 6 out of that 24. What is left is 18 valence electrons. Now there are 18, we have to distribute them. You take those 18 and go to terminal atoms and complete their octet. There are 3 oxygens, so I can place 6 in there. Now the octet is complete. I can place another 6, octet is complete, and another 6 here. So now there were 18 initially. I placed 18 on these 3 oxygen. What is left is 0. I don't have any valence electrons. But if you look at nitrogen, nitrogen doesn't have 8 electrons. Nitrogen has only 6 electrons because there are 3 bonds around nitrogen. So but nitrogen needs 8 electrons. Octet must be completed for nitrogen. How can we do that? You can share one of these pairs with nitrogen. If you do, what we get is this. You make basically a double bond between nitrogen and that oxygen. Nothing happens to this oxygen, nothing happens to the other oxygen. So now the electron distribution is, we have 2 pairs on this oxygen. We did not do any change to other 2 oxygens. So now if we calculate the formal charge of nitrogens and oxygens, especially nitrogen. Nitrogen is in group 5 valence electrons, minus the number of lone pair electrons on nitrogen, which is 0, you don't see any dots, plus half of bonding electrons. There are 4 bonds, 8 electrons, we need the half of that, which is 4 electrons. 5 minus 4, which is plus 1. The formal charge is plus 1. So a minute ago I said, if you see a formal charge of plus on the central atom, it is a red flag. We must try to minimize it, try to make it to 0. We can do that by making double bonds, right? So that is what we did so far. But in this case, the formal charge is plus 1. What I can do is I can take one of these lone pairs on oxygen and share with nitrogen, make a double bond. I can get rid of that plus 1 formal charge. When I do that, I can't do it. That is my point. That is the point I'm going to make. I can't do it. If I do it, nitrogen will have not 8 electrons, 10 electrons around it. So nitrogen will have 10 electrons, but nitrogen cannot have 10 electrons. Maximum nitrogen can have is 8 electrons. So that is why I wrote this point. The period 3 and above can have more than 8, but not others. So nitrogen is in period 2. So nitrogen cannot have more than 8 electrons. So in this case, we have to leave this structure as it is. So this is the right Lewis dot structure for nitrate ion. The formal charge of nitrogen is plus 1. Okay, let me write it down. I assume when you read it you will understand. Okay, you understand what I am saying here. So if you make that second double bond, nitrogen will have 10 electrons around it, so which is not allowed. Let's do one more example. So let's look at this molecule, NSF molecule. So let's see whether we can write the Lewis dot structure for this. So there are three elements, nitrogen, sulfur and fluorine. Let's calculate the number of valence electrons first. So nitrogen is in group 5, 5 valence electrons. Sulfur in 6 valence electrons. Fluorine is in group 7, 7 valence electrons. So it is 18 valence electrons. So what can be the central atom here? So nitrogen is the first element written. Okay. However, nitrogen is not the central atom. Sulfur is the central atom because sulfur has the least electronegativity compared to nitrogen and fluorine. Remember that series, the sequence. Fluorine, oxygen, nitrogen, chlorine. So sulfur is not in that series. So the electronegativity of sulfur is less than nitrogen and fluorine. So sulfur is going to be the central atom. Then there are two atoms, nitrogen and fluorine. So I'm going to create my skeletal structure. So that is 2 lines, 4 electrons. I had 18 valence electrons first. Out of that, used 4 to create the skeletal structure. Now there are 14 valence electrons left. Now you go to terminal atoms and distribute these electrons. Basically you complete their octet. So there are 14 electrons. Let's go to fluorine first. Why? Because it is the most electronegative element. So we have to complete the octet of fluorine first. So used 6. There were 14. Let's go to nitrogen. So now out of 14 we placed 12. There are 2 valence electrons left. In that case what you do is you take those leftover valence electrons. Once you complete the octet of terminal atoms, you go to the central atom and place those leftover valence electrons as lone pairs. There were 2. So now I have put 2 electrons on sulfur as a pair. So now let's check whether these have right number of electron and the formal charge. So if you look at nitrogen, nitrogen has 8 electrons, 6 plus that bonding electron, 2, 8. Fluorine has 8 electrons, 6 dots plus 2 bonding electrons, 8. If you look at sulfur, sulfur has 2 dots plus 2 bonds, 6 electrons. The octet of sulfur is not complete, so we have to complete it. How can you give sulfur 8 electrons? By making a double bond between sulfur and terminal atom. But here I must make the double bond between sulfur and nitrogen, not fluorine. I'll tell you why in a second. Okay, let's make the double bond between nitrogen and fluorine. Basically just give one of these pairs here to sulfur, share it with sulfur. Then what you get is, so you make a double bond, nothing happens to fluorine. Now the electron distribution is, so there is a pair here, nothing happened to these electrons, and now nitrogen has 2 pairs. The sulfur has 8 electrons now. So now let's check the formal charge of sulfur. I'm not going to do it in detail, but you can calculate. The formal charge of sulfur now is +1. The formal charge of fluorine is 0. Formal charge of nitrogen is -1. So if you don't know how we got this, please go to that formula and calculate. So now sulfur has +1, which is not right. Sulfur is in period 3. Sulfur can have more than 8 electrons. So that tells you we can get rid of that +1 formal charge. How can I do that? I can make another double bond. Where am I going to get that electrons? I'm going to get it from nitrogen again. So now I have this structure. So now you may be wondering, why didn't I get those pair of electrons from fluorine? Okay, just hold that thought. So now we did not do anything to fluorine. Now we have 3 bonds between nitrogen and sulfur. Now the electron distribution is nothing happened to the lone pair on sulfur, nothing happened to the electrons on fluorine, and nitrogen has only one pair. Now if you look, the nitrogen has still 8 electrons, fluorine has 8 electrons, sulfur has 6 plus 2 8 plus 2 10. Sulfur has 10. If you calculate the formal charges of these atoms now, nitrogen is 0, sulfur is 0, fluorine is 0. So this is the best scenario because all are zeros. That is the best. So this is the Lewis dot structure for NSF. So now you may be wondering, why didn't I make any double bond between sulfur and fluorine? I think I mentioned it. When you have halogens as terminal atoms, we do not make double bonds. The reason why is, when you do that, the halogen gets the positive formal charge. Just to make that point, I'll show you. Okay, so we are done from here. So this is the right structure. Let's say we make the double bond. Once we get to this point, the second molecule, I'm going to make a double bond between sulfur and fluorine like this. So now the electron distribution is, fluorine has 2 pairs and nitrogen has 4. So again, this is not the right structure. The right structure is this one. So now if we calculate the formal charges, nitrogen is -1, sulfur is 0. For fluorine, it is +1. If you don't know how to calculate, again, please read the notes before. So look at that formula and see how to calculate. So fluorine is in group 7, 7 valence electrons, minus there are 4 lone pair electrons, okay, 7 minus 4, 3, minus there are 2 bonding electrons. So 7 minus 6 is +1. Fluorine is the most electronegative element in the periodic table. So we cannot give a positive formal charge for most electronegative elements. So that is why this structure is not the right structure. It is an unstable structure. I think you understood what I was saying. So the most electronegative element cannot have the positive formal charge. Because of that reason, this structure is unstable. So the most stable one is this.